Hi, this video takes a look at independent samples, this time looking at difference of proportions. Our previous videos have dealt with difference of means, so we're changing gears a little bit. So yeah, this is appropriate for nominal and ordinal level data as opposed to interval and ratio, which we've been dealing with. And testing the difference between proportions, we take a look at the question of do two groups differ in their percentage of some characteristic. So the logic is basically the same statistically, although the math is a little different. So what do we need to calculate our test statistic? That's ultimately what we need to do to complete our significance test. And there's a few pieces to it. We need to have our point estimate, which is just P1 minus P2. When it has carets over it, it means we're talking about the sample. This is the population, so this is going to be 0 when we do the math, because we don't know. We assume it's 0 for a null hypothesis. And we need to know the standard error of the estimate, which is over here. So in order to get the standard error of the estimate, we need to take a look at what's called the pooled proportion and its converse, or opposite. So the pooled proportion is going to be the group 1 and group 2 number of individuals and whatever characteristic we're studying over the overall pooled sample sizes, n1 plus n2. And then we find Q just by subtracting this from 1. Once we have our pooled proportion and its converse, we take the product of that, multiply it by 1 over sample size 1 plus 1 over sample size 2. We take the square root of all that to get the standard error of the estimate. And that goes in our denominator for our test statistic. And that is P1 minus P2 over the standard error. So let's look at an example. Recent surveys stated that male college students smoke less than females. There's 1,245 male students and 361 said they smoke at least a pack a day. And of 1,065 female students, 341 said they smoke at least a pack a day. We're using an alpha level of 0.01, so we want to be 99% confident in the results. And let's take a look at the results. So here's our pooled estimate for this particular study. So that's going to be the group 1 and group 2, the smokers in the numerator, and then the pooled overall sample size in the denominator, so 702 over 2310, which gives us 0.304. And then simply subtracting that from 1 gives us 0.696 for the converse proportion. And we will use that down here, right, when we calculate our test statistic from our standard error of the estimate. And so we're going to plug all the values in. We have the proportions, 0.29 minus 0.32. Again, this is 0. These are the population proportions, which we assume the difference between them will be 0 as the null hypothesis. And the denominator, our standard error, which is this portion here. Our pooled proportion, 0.304 times its converse, 0.696, goes there. And we multiply that by the sum of these two things, 1 over sample size 1, 1 over sample size 2. And when we do the math, we come out to a negative 1.56. And the cutoff for our test, remember at the alpha 0.01 level, which is pretty strict, is negative 2.33. That's actually somewhere over here, so move that there. Okay, so anyways, it's very close. Oh, sorry, we had that in the right place, didn't we? So the test statistic, 1.56, negative 1.56, is well within the non-rejection region. So we're going to fail to reject the null hypothesis. And what that means is there is not enough evidence at the 1% level to support the claim that male college students smoke a lower proportion than females.